Assalamu alaikum warahmatullah. So this is the latest example 4 of module 10. We are speaking about the timers. So in this example we will speak about the CTC mode. So in the previous examples we used the compare manually. So in the previous examples we compare the value of the register which is containing the value of the timer manually. The concept here in CTC is similar, but things will be done by hardware. So we have 2 points, the set point and the process value. In every iteration, the microcontroller will compare the process value with the set point. If the process value becomes equal or exceed the set point, the process value is reset. Previously, we did this manually. So we check if TCNT 0, 1 or 2 according to which timer we are using. So let's say we are using timer 1. So we compare. If it's rich, we do some action and reset the value. We will do the same using the CTC mode. As you know, timer 1 is 16-bit and it can count up to 65,535. So in the example, we are using 39999, so it is still in the range of the timer 1. In the CTC mode, the same thing is applied, but as I said, using the hardware. So the comparison will be done when the process value is equal to the set value, an interrupt will be fired. So this will help reducing the needed cycles and ensure greater accuracy. Hence the comparison takes place in the hardware itself. Inside the AVR CPU, the process value becomes equal to the set point, a flag in the status register is set, and the timer is reset automatically. So no need to put the value TCNT 1 or whatever the timer we are using to 0 again. It will be done automatically. So the CTC is clear timer on compare. So it will be cleared before reaching its maximum when it reaches the set value. Thus all we need to do is to take the care of the flag, which is much more faster to execute. Let's see this example. Write a program to flash LED every 100 milliseconds. So it's a little bit long time comparing with the previous example. The question asking us to use CTC mode, clear timer on compare mode of the timer. We have a crystal which is 16 megahertz. So solution, we start by calculating the timer count. We calculate the T, the period, which is 62.5 nanosecond. The maximum for timer 0 is 15 microsecond. The maximum for timer 1 is 4.01 microsecond. Okay, if we are using the same clock. So we need a prescaler because even timer 1 is not sufficient. The prescaler, in simple calculation, we will find that 64 prescaler is enough to reduce the frequency to 250 kilohertz. So T will be 4 microsecond. The new prescaler will give new T. We calculate the new timer count and the result is 24999, which is in the range of timer 1. Now, instead of compare the value is 24999 as we did before, we will use the CTC mode. How to adjust the CTC mode? Of course, using the TCCR1 A and B in timer 1. So if we want to use the CTC mode, we need to set WGM13, WGM12, WGM11 and WGM10. So these are the values that are used for CTC mode. So we can use this one if we want to use the OCR1A, or this one if you want to use the ICR1. Okay, so we are going to use this mode. So we need to set WGM12 to 1 and leave the others 0. So here in TCCR1B we set WGM12 to be 1. These values are used for the pre-scaling. Okay, so we set the pre-scale to 64. After setting the CTC mode, we must tell the AVR to reset the timer as soon as its value reaches the comparing value. So the question is, how do we set the compare value? The output compare register 1A OCR 1A and the output compare register 1B OCR 1B are utilized for this purpose. Since the compare value will be 16-bit value, which is in the range of 0 to 65,535, OCR 1A and OCR 1B are 16-bit registers. In Atmega 32, there are two CTC channels, A and B. We can use any one of them, and we are going to use the CTC OCR 1A channel. So we just put the required value in this variable. So OCR 1A equal to this value, and that's all what we need to do. Now we need to check the TIFR register to see if the overflow on compare happened. So OCF 1AB, which is the output compare AB match flag, this bit is set 1 by AVR automatically whenever a match occurs. So if TCN T1 becomes equal to OCR 1A in our case, or OCR 1B if you use it, so in our case we are using OCR 1A, it's cleared automatically whenever the corresponding interrupt service routine ISR is executed. Or we can clear by write 1 to it manually. So now let's see our program. So simply include AVR IO.h. We do the initialization, set WGM12 to choose the CTC mode, and CS11, CS10 to set the prescaler to 64. We initialize the counter and we give the value 24,999 to OCR1A. That's all what we need to do. In the main program, we set DDRC to bit 0 to 1 because this will be our blinking LED. So this is our output. We call this one, and all what we need to do is to check if the TIFR received the interrupt on compare. So when we receive the interrupt on compare, we toggle the LED. No need to compare the value, it will be done automatically. We just wait to receive the interrupt in the TIFR register. And because there is no ISR function called, we need to set OCF1A to 1 again. So this is all for the CTC mode program. Now we go to the circuit and see how it's run. Using the same circuit, we upload the new program and build it. Then we upload it to our microcontroller simulator. We upload the hex file and we run the simulation. As you see, the result is just blinking LED D1. Okay, it will take longer time because it's set to 100 milliseconds. Of course, it's taking more time because the simulator is not running in real time. It's just to simulate how things is going on. Thank you for listening and see you in next video.